Hi, my name is Hongliang. I'll introduce our paper, Exploiting Semantic Relations for Fine-Grained Entity Typing. Fine-grained entity typing is a task that aims to recognize the fine-grained types of a mention in a sentence that matches the context. In the example below, the entity mentioned Trump should be typed as person politician. Although Donald Trump also has other types, such as businessman, TV personality, they do not fit the context and thus should be regarded as incorrect. A typical neural approach to this problem that is used by many existing studies is to first get a representation for the mentioned string, then get another representation for the context, and finally concatenate these two representations and feed it to a classification layer. We find that such an approach may overlook some useful semantic relations. I will use two examples to illustrate this problem. In this first example, connote should be typed as organization, corporation. However, a state-of-the-art system only predicts organization. If we take a closer look at the sentence, we can find that the word concern is a hypernym for the mention. So if we know that connote is a concern, then we can naturally type it as organization corporation. However, this hypernym relation is not used by the existing system. Here's another example. In this example, the mentioned salty dogs is a drink and should be typed as substance food according to the dataset. However, the system incorrectly predicts work of art. We can notice that a salty dogs is a patient of the verb drink. Such verb-argument relations can be obtained through semantic row labeling. And if we know that salty dogs is something that can be drunk, then it should be a drink and it should be typed as substance food. However, this verb-argument relation is also ignored by the system. Thus, we propose an approach to exploit hypernym relations and verb-argument relations that are related to the entity mentioned to improve fine-grained entity typing. Here's the general framework of our approach. Firstly, it contains three individual components. The base FET model is a neural model that has a similar structure as the typical neural approach I introduced previously. The hypernym relation-based FET, it first extracts hypernyms for the mention and then use the extracted hypernyms to make FET predictions. And the verb-argument relation-based FET, it makes predictions based on verb-argument relations that are obtained through semantic row labeling. And finally, we have a gating network. It is a small neural model that produce the final prediction by combining the predictions made by each individual component. That's all. If you are interested in getting more details, you can read our paper.